All right, guys, in this section, we're going to continue on with something called process control instrumentation. So what is this? Well, okay, there's got to be things in place that actually control some of these operations that we've been talking about, right? So now we're going to dive a little bit deeper into what those pieces and parts might be, so that way I can use those to help me do my job. Well, before we start talking about some of these, we've got to talk about words. That's right, terms. So let's talk about few terms that they like to throw around that they just expect that we know. So first off, are these things called set points. All right, so I think that those are somewhat a type of self-explanatory. Set points are basically targets. These are things that we can go into the manufacturing line and say, I do not want it below this level. I do not want it above that level. I want it at this level. Those could be set points. So these are temperatures, or these are pH levels, or these are DO measurements that we want this manufacturing process to stay at. So those are going to be step points. Those are targets. That's what we're after. That's what we want every single time that we go to that process of the manufacturing line. Those set points better not change. At least we hope that they don't. If they do, then what we're getting ready to talk about is going to help us manage some of those changes. Next up are sensors. And sensors are just pieces of the puzzle that collect information. So, for instance, a pH probe might be a sensor, and that is collecting information, and that is storing that information, and that is relaying that information later on down the road through all of the wires and the networking and the computer systems that might be in place. So these sensors can come in many forms and many sizes with many different aspects to them, but overall, the goal of using a sensor is just that. It's something that's collecting a measurement for you, and that measurement is probably one of these variables that change, and we've listed those, but at the same time we can keep track of everything that's going on at every step along the way throughout the entire day after day, week after week. Thank you, sensor, for taking these measurements for us. Next up are transmitters, and transmitters are just the thing that takes that information and sends it to where it needs to go. So it's transmitting a message, right? So back in the day, of course, telephones, hardwired, we got to have a transmitter. We got to have it, be able to talk and get that message to somebody else. Well, this is what a transmitter is here. It's taking information from the sensor, and it's relaying that information to the thing that will be doing the work for us. Now, very often, these sensors and these transmitters are going to be built together, but we still like to talk about them separately. We still like to term them separately, but that is taking the information and it's relaying it to some form or fashion within the whole networking aspect of a manufacturing facility. Next up are controllers, and controllers are the things that are like the brain of the operation. So they're going to be taking the signal that has been relayed through the transmitter that has came from the sensor, and they are going to interpret what to do with that information. So that's why we say here on the screen that they are actually going to be making the decisions. So that's what the controllers do, and I think that again makes somewhat common sense. So controllers are instruments that compare conditions and make decisions and sends a signal to the final control element. Now we're going to talk about that in just a second, but again, this controller is going to have a built-in system in place where it says, hey buddy, the temperature is way over this amount. Please do something about it. And that controller will be, okay, yeah, I'll get right to work. Thank you for letting me know, transmitter and sensor. So then that controller is going to send a signal. It's going to send a order. It's going to send a command to what we call the final control element. The final control element that you see on the bottom of the screen, that is actually what is doing the work. So it is receiving that order from the controller, and that final control element says, oh, okay, you want me to increase the pH? Okay, not a problem. I will open up this valve and we will flood in whatever solution that's going to be used to do that, and then we'll close that off when you tell me to close it off. That is how this whole system somewhat works. So, set points, You will determine, a person will determine, the company will determine. The sensors are working all the time. The transmitters are working all the time. The controllers are seeing data all of the time. And the final control element is sitting there waiting. So that way, if it needs to do something, the controller can tell it what to do, and off it goes. All right, so more terms that we want to talk about here. First off is this data logger. That's just a recorder, all right? And this is something in-house that's going to be recording that data all the time, folks. So, there's times that we've got to go back and we've got to look at logs, we've got to look at times, we've got to look at dates. Auditors might be coming in and they might want that information as well. So something has to be recording and giving us kind of a permanent record of everything that's going on all day long. And that is what a data logger is, and that's its purpose. So again, if I'm measuring temperature, then that temperature readout, whatever it's going to be, well, we can have access to it, 1 year, 2 year, 3 years later down the road. We can go back and we can pull up a date and we can pull up a time and we can say, no, that vat that we fermented was at this temperature because my data logger told me that it was. So very important piece of the puzzle. And again, regulatory purposes love to see this type of information. Next up is an indicator, and the indicator says it's a device that graphically shows the values of the controlled variables. All right, so this is just graphically what's happening. That's what kind of an indicator is. So what that means is that it's keeping track of information, and then as that temperature is going up, there is a line that goes up, and then as the temperature goes down, there is a line that goes down. And visually we can kind of see this data in a different type, in a different way, not just numbers, but some kind of graph that's drawn out on a sheet of paper that tells me the fluctuations throughout the day, throughout the week, throughout the month. So indicators are very useful, especially to get an overall idea of the data that's happening throughout your time while you're there on the plant. Two other terms that are here at the very bottom are something called analog and digital instruments. I think you know what that is. So analog instruments are just things that I would call maybe old school, but it's not old school to me. I mean, I grew up that way. So the analog instruments, I want you to think of the kind of analog clocks. Back in the day in kindergarten, we had to learn how to tell time. We didn't have anything digital like our cell phones that just told me the hour and told me the minute. We had something a little bit different, and we had to read the face of a clock or a watch. So, think of kind of like, oh, okay, well, this is an analog instrument. All right, that's what that is. So anything that has a valve, anything that has some type of meter on it that we have to read, that we have to interpret, that we have to log, that is going to be an analog instrument. So again, if I step on the scales, you've got two versions of those. You've got the old-timey scales, which again is what I grew up with because I guess I'm old-timey. So I step upon these scales and I see that dial go forward, and it might go forward more than what I want it to go, but it's going to go forward and it stops at a number. I have to interpret what that number is. Okay, well, I squint my eyes and I'm like, oh, okay, I'm going to shave 5 off of that. That's what I'm going to pretend that number is. So as you can imagine, analog instruments, well, they're kind of fishy because in a manufacturing type of setting and even in a laboratory type of setting, if we're using someone's judgment, that can be very, very tricky because are they reading the scales the proper way? And are they understanding what that kind of needle is reading on that scale or on that meter? So analog instruments slowly go away, and then we get digital instruments that come into the picture instead. And those are ones that actually provide us values. They're the ones that are providing us numbers. So now I can step on a scale, and now that scale is just going to pop out a number, and I read that number. I don't have to read a scale myself. I don't have to interpret anything. It is just the value that is point blank right in my face. Watches, cell phones, all of those are now digital, of course. So these are items that I can look at. They're instruments that I can look at. It gives me that value. That value is the time of the day. And I don't have to interpret a clock, an old-fashioned type of clock. But, again, depending on when you grew up, you might actually like those better, because sometimes I do, it seems like. All these systems can also be what we call manual controlled or automated. And of course, manual control, it's the operator. The operator is the one that is doing it. The operator is the one that's collecting the values, logging the values, making a little notebook full of all of this information. That is going to be part of the manual control process. And it's very important that you keep a detailed log of everything that goes on in a manufacturing line. So it is wanting you to look at the set points. It's wanting you to look at the minimums or the maximums or record the values at that moment in time. You might be tasked to record these values every hour, every 30 minutes. Who knows? That is up to the manufacturing company. That's up to the process. That's up to the stage that you are working in, but it is very person involved. And then not only that, but if you have to do something to fix it, well, it's the operator that makes that decision. So we are relying on you, and the company's relying on you, if it's a manual process, to record these measurements over a course of time, be very detailed about it, and if you see something go out of specification, then you need to make a decision on how you can fix that to get it back into specification for the manufacturing process. So those are the types of things that you would experience if this was a more manual type, hands-on involved process or manufacturing line. You can also do automated. That is perfectly okay as well. And what that means is that it takes a lot of that responsibility off of you. So these are instruments that are coming in. Again, they are recording, they are logging that data into a computerized system. They are keeping track of it day after day. No one can say, oh no, I forgot because I took a coffee break and I didn't write down the temperature. The machines just take over. And at the same time, the instruments can make their own decision, believe it or not, on what they want to do. Not quite Terminator style, but still machines can get involved into the decision-making process, and they can help us to determine, well, what do we need to do? How do we need to do it? How long does it need to be open for if that is a valve that gets turned on? So those are the types of things that the equipment can help us with in the manufacturing process. So manual versus automatic. Manual, again, is more person involved. You are involved in that entire process and you take responsibility in it. The automated ones are just instruments that do it for us, so that way we can go do other things with our time instead of worrying about logging data and logging information for hours upon end throughout the shift that I begin to work on. We do have these things called PLCs, and PLCs are something that stands for Programmable Logic Controller. You're probably going to see that again. I would guarantee that you're probably going to see it again on some type of online quiz or a test. And PLCs are just continually scanning data. They are gathering information. And what it says is that it's scanning the software ladder logic program. So what that basically means, it's just like a ladder. Okay, so here we go. And then there's a run, and there's a run, and there's a run, and there's a run, and there's a run. So PLCs are going to check the inputs. So these are inputs that you have set. So I'm going to say we've got a biofermenter, and that biofermenter is going to have a temperature, and that temperature should be maybe 60 degrees. Who knows? So I'm going to key in 60 degrees. That is an input that I have put in. So the PLC will take a look at that 60 and understand, okay, that is an important number. That's something that we need to pay attention to, and that's something that we need to track. Number 2, it says execute the program, and then number 3 says update the outputs. So in a roundabout way, we are going to execute a program program, which means begin it, and then it's going to update all of the outputs of that instrument. So it's going to constantly monitor, it's going to constantly report maybe what that temperature is, and it will constantly repeat itself. So it will go and self-check over and over and over and over. So as you can see at the bottom, it says the cycle repeats as many times per second, and it allows the program to control the process through physical devices that are inputs and outputs. So in other words, it can take that information and then it can send a trigger down to a valve to close or down to a valve to open. It can send a trigger to a hot water tank and it can say, open that please and give us some water because we need to circulate some heat through the bioreactor so that way we can keep it constantly at 60 degrees. That is what we call a PLC, or programmable logic controller. Some other terms that we want to talk about before we end this video. One's a DCS and the other one is an HMI. So I know a lot of abbreviations, but don't blame me. I didn't do it. So DCS and HMI, again, lingo terms that are going to be used out in the manufacturing field. A DCS is a distributed control system. So what this is, it's a software package, and I want you to think of that software package as like a bunch of little octopus arms, and it's got its arms in every little aspect of the manufacturing facility, so it can control as many of the plant functions as you want it to control. So that is a distributed control system. So control system means, okay, that is something that's giving an order, and distributed means throughout the entire plant. So hence a DCS. Next, technicians will access the PLCs or the DCSs through what they call a human interface machine, or human machine interface. All right, I like human interface machine a little bit better, but that is what an HMI stands for, and the term is human machine interface. So those are going to be very often things like computers or things like touch screens, where you are up at this screen and you are touching and you are inputting and you have an interactive moment with that controlling system. That is an HMI. HMIs overall, they are very good because you've got access to some of the data that it's collecting. You can visualize maybe the data points that is happening in real time at that HMI. You can also look at logs and look at graphical representations of what's been going on through that HMI. So again, I want you to think of this as even maybe your cell phone is a human machine interface. There's so many things that you can do, and there's so much information that you can gather through that, and at the same time on the backside that you're not necessarily seeing, it is gathering information. What websites have you been visiting? And it's reporting that information. Oh no, did you check the box that says don't give me cookies? Well, okay, either way, it looks for trends. It looks at those variables that you have set. It allows you to change set points. It allows you to go and do overrides. It will identify where there's an alarm going off if something does go out of specification. And it allows you to see what we call the status of the equipment. Is it online? Is it offline? Is there a problem? Is there something that needs to be addressed? All of those are very interactive moments that you have with these computerized systems, and again, we can call those an HMI. Finally, in this video, we're going to talk about data integrity. Notice that throughout the past 18 minutes, I've talked a lot about set points, about entering values in, monitoring these values, making sure they stay constant as much as possible. And all of that is, of course, going to be called data. So data integrity is very important, and the reason for that is because we cannot lie, and we cannot say, oh no, yeah, that was at 60. Yeah, no one ever knows. Shh, be quiet, it'll be our secret. Data integrity, that's what this is. It is a way that we can log information. It's a way that we can monitor this information and then provide it to someone else that would like to see that information at any moment in time. So for instance, if I was was running a company and I wanted to know, well, why my product didn't work out, I might would want to see some data logs, and I might would want to go to that fermenter and be like, okay, let me see the track of the temperature, please. I want to make sure that you actually monitored the temperature like you were supposed to, because if you did that, that's part of your standard operating procedure, and we should be getting the product that we should be getting. So please let me see that data log. Well, by involving computerized systems, these computerized systems, the data integrity is very, very good. As you can imagine, it could be very easy for someone to, a little white lie won't hurt nobody, will it? And they will lie about the temperature, and they could write that temperature onto a log sheet, and nobody will be the wiser unless someone's there that's going to tattle on them. So if they've got a little partner in crime, then, you know, hey, I can initial it, you can initial it, everything will be okay, nobody will ever know. But data integrity with computerized systems are a little bit harder to fudge and a little bit harder to lie with. So integrity, very, very important, not only for the company, but also for third parties, also for regulators and everyone else that's involved in the company as well. So it allows data to be available. Of course it does. And it creates documents that we can print off, that we can file. If you like hard copies, great. If you like electronic copies, absolutely. It's going to do both of these for us. It's also going to tell us who entered in the data. So if this was an automatic measurement read that an instrument will take and log, then it will state that. But if you have keyed it in, if you have interfaced with it in some form or fashion, then that means your name is going to be assigned to that data sheet as well, as a reviewer, as an inputter, or whatever the case might be. Data should not and data cannot be altered, which means changed, deleted, omitted, or in any way modified to represent what actually happened. All right, so I'm going to I'm going to circle that and make a lot of horrible, awful noises. And the reason that I'm doing that is because that statement is very important. That statement is important for the integrity of the company, not just you, but the company as a whole. And if data integrity and the integrity of the company begins to fall, then guess what? All of you are out of a job. So why would you allow something like that to happen? Please do not be that person. Please do not work for that type of company. That data should be presented. That data should be logged. That data should be recorded as it is taken and as it is saved. There is no thing as bad data. All right. Now, of course, there might be data that causes some confusion, or data that causes you a little bit of hesitation, or data that causes the plant to shut down because it is not matching what it should be matching. And that is okay. No one says that we've got to work in a perfect world, but data should not be fudged. Data should be the highest integrity as it can, because fudging that data can actually not only send the company into lawsuits, but guess what, folks? You signed off on it. You could be legally responsible for it. So if you are inputting values that are not correct, if you are making assumptions or going through this process and analog reading meters or whatever the case might be, and you are recording those phony results, or you're just making it up, knowing that you're making it up onto a data sheet, then you could also be in the courtroom chair when they begin the trial process, when they begin to sue the company or whatever the case might be. And sometimes these people go to jail, right? And you do not want to be one of those people. So data integrity, very, very important. Not just on manufacturing, but the laboratory side of the house has to deal with that too. They are also generating data. They've got to feel really good about the work that they do, and they've got to make sure that they have things in place that back it up. Because if they don't, then they're lying. It's phony data, and they can easily go to the courtroom as well and be interrogated by lawyers all day. And nobody even wants to be seeing a lawyer, much less interrogated by one. All right, so that's going to finish up section 6.6. 6.7 is going to look at this manual versus automated control again. It's going to go through this process of, describing a little bit more differences between them, giving you some more terms. But that's where this video is going to end. So in the next one, this is where we'll pick up, and I'll see you then.